Okay, this video is going to walk through number 10, which is the last problem in your notes. So let's look at this. It's a degree 4, and in this particular problem, you are given a root to start with. So you're given a root to start with. You're given 3/5, but I still want to walk through every single step so that you know what you're responsible for with each of these problems. So to get started, you're always asked to list the combinations of complex roots, real and imaginary, the number of each type. I have a degree 4, so I could have 4 real, no imaginary, 2 of each, and no real and 4 imaginary. Remember, imaginaries occur in pairs, and when I add them together, I need to get the degree of the equation that I'm working with. The next thing you're always going to be asked to do is come up with your root pool candidate. This is what I call it. These are your rational roots, meaning that if you do have real number roots, it's possible that they'll be rational, integers or fractions. Notice I'm given 3/5, and here you can see I've got 3 in the numerator and 5 in the denominator right here. So the way that I've created this list is I am looking at, I already did it for you, but let me go back and recreate it. The numerator is, and I'll color code it here, the numerator is comprised of factors of the constant. So 1 and 3 are factors of the constant. The denominator is comprised of factors of the lead coefficient. The lead coefficient is 15. So my denominator will be factors of 15, 1, 3, 5, and 15. And notice that the given root is 3/5, and I could pull that root out of this list. So 3/5 right here. That's a given root for me to work with, and you can see that my little P/Q test for rational roots holds with this. The next thing you would do if you were not given a root, the next thing that you want to do in this process is find a root to work with in your synthetic division. So the root or 0 is what's going to go in that divisor spot in synthetic division. So you always want your divisor to be a root or 0. So your divisor should be a 0 or a root, because you don't have time to waste going through the process for something that's not going to give you the result that you want. The reason why you know it's going to be a root or 0, you want that remainder of 0 at the end. You always want the remainder to be 0 when you go through the synthetic division process. So in this particular problem, you were already given a root to get started with. So I'll go ahead and set this up. So I've got the fraction 3/5. It's going to go outside the box, and then I copy all of my coefficients. And then I start the process. So 15 drops down. I multiply 15 by 3/5. Drop this down. 15 divided by 5 is 3. 3 times 3 is 9. So that gives me 9. Adding these together. And as always, if you start getting weird numbers that are not divisible by 5, go back and check your arithmetic to make sure you don't have an error somewhere. And then here, finally, I get +3, and you're adding these columns together. Remember, you're adding, not subtracting. And when I add those together, I get the remainder of 3. Now, you can cheat and use your calculator, but you're still responsible for the skill. So just let the calculator be a support tool. Don't rely on it to answer all of the questions, because you do have to understand the skill itself, the theory behind it. Now, the reason I did this, I'm starting with a degree 4. This is going to give me a degree 3. So I've lost a degree, and let's analyze what I have here. I've got 15x cubed. And maybe this is something I can factor. If not, we will repeat the process again. And here, I'm going to remove a GCF of 5 across the board. And I don't think I can factor that. So that means I have to repeat the process. So I need to repeat the synthetic division, and I'm going to repeat it. I'm going to repeat the division on what's inside the parentheses right here. I'm going to repeat the process using this degree 3 poly, but I need to find a root. So I need to find a root to use. I always like to test positive and negative 1 in function notation, f of 1, f of negative 1, using your function notation, just letting x become 1 or negative 1. If it gives me 0, if it results in 0, then I know that I found what I'm looking for. When I test x equaling positive 1, it doesn't equal 0, but when I test x equaling negative 1, it does equal 0. So I'm going to run through the synthetic division process the second time using this divisor. I'm going to let my divisor be -1. So I'll set this up again. I'm going to use what's highlighted in green. So I'll draw my synthetic division box, and I'm going to use 3, 7, 5, and 1, and I'll highlight this in green. So I'm getting these numbers from the outcome of my round 1 of synthetic division, and I'm going to let my divisor here be -1. Which is what I found above right here. So I got the -1 right here by testing f of -1. And I know that when I get to the end right here with this, I know that my remainder here is going to be 0, which is exactly what I want it to be. My remainder will be 0. So here we go. Let's go through the process just to verify that we're right. So I'll let 3 drop down. And +1 times -1 is -1, giving me my remainder of 0. Let's see if we can factor this. I was at a degree 3, so now I have a degree 2. My outcome here is a degree 2. So I've got 3x squared, 4x plus 1. I need two numbers that multiply to 3 and add to 4. That would be 3 and 1. And that's going to give me 3x plus 1 and x plus 1. And you can factor that as you wish. You can factor it with slide divide or big X, factor by grouping. I will let you factor that as you wish. But now I'm finally ready to pull all of my factors together and all of my zeros together. So my factors and my zeros. My factors, let's see, I was given a root of 3/5 to work with. So that means that the factor associated with 3/5, my 0 was 3/5, which means the factor associated with that was 5x minus 3. 5x minus 3. If I set 5x minus 3 equal to 0, that would give me 3/5. That's my first factor. Moving on, moving back up, looking back up. Let's see, we use -1 as a root in our synthetic division. So -1 is my next 0, and the factor associated with that would be x plus 1. And then I ended up with this quadratic that I was able to factor. So here my factors are 3x plus 1 and x plus 1. And the roots coming out of that would be -1/3 and -1. So notice that I've got here, -1 is actually occurring twice. I had a degree 4, and one of the combinations would be 4 real roots. So I had 4 real roots. -1 is occurring twice, but it still counts as 2 roots. Hold on, I didn't mean to do that. So -1, even though it occurs twice, still counts as 2 roots. So that is a complete problem. That's a complete problem. And I'm going to scroll back up and look at this all again. So this is the entire process. You are given a root to get started. You always have to list the combination of real and imaginary roots. Then you list your rational root candidate pool, factors of the constant over factors of the lead coefficient. If you're not given a root to get started with, then you have to find a root to get started with, and that comes from the P over Q or testing positive and -1. If none of that works, then just go to your graphing calculator and see if you can find a root to get started with. So here we used the root that they gave us, which gave us a degree 3 poly. Then we had to repeat the process again, but this time we had to find our own root to go through the synthetic division process with. And then finally, we ended with a degree 2 that we were able to factor.